equations with fractions, there's a rule. You don't want fractions. So when it's an equation, we can get rid of fractions by doing LCD. But before you can look at the LCD of these denominators, all of them have to be factorized. Because then I can see the lowest common ones. If they are all broken down into their smallest factors, then I can see the lowest one. So we'll start off with quadratic trinomial, which was
X minus 3, X plus 1.
on your technique of factorization, which is your lifeline in maths, factorization. We have got x minus 3 as a bracket. So we time with a negative, and we time with a negative, and we get a positive. And we've got x plus 1. You just put the brackets around it, because then it's factorized. Not really factorized, just to show the factor. To show that 3 minus x, why do I change the sign? We're looking for a common denominator. So I don't want x minus 3 and 3 minus x, because it's not the same. Making them the same. This would be the more logical choice, but it doesn't mean you cannot go and change this one to be 3 minus x, changing the sign in front as well. There's an option. Normally, you saw this one, you saw that one was different, changing that one. You're timing with 2 negatives to bring around that change. So making 3 minus x, x minus 3 is 1 minus. Then timing it with another minus in the front, because then I'm timing with 2 and I'm not changing the sign. You can do all sorts of wonderful stuff, but it has to be mathematically legal. So that's the legal stuff. Then what is the LCD? X minus 3,
X plus 1,
x plus 1,
X minus 1.
Was that one x minus 1?
Yes.
No, the last one, ma'am.
So that's the LCD.
No, ma'am, the last,
The last one.
term after the.
It's x minus 1.
It's x to the power of x minus 1. How x? Oh, x
I'm not seeing the mistake.
Let me see by equal.
This is the correct one. Right?
Yes, ma'am.
So from that, your LCD is only x minus 3, x plus 1. I remember the one that I did was something else. Unfortunately, let's do it this way. Most probably that one wouldn't have worked out then, because you had too many factors. You would have gotten to something that you're not able to handle, like a cubic thing. Okay, so let's do the correct one. Now the LCD for this is x minus 3 and x plus 1. What do we do with it? You time each and every term with it. Times this one also with it. Times this one also with it. With the what? X minus 3, x plus 1. And if you need to do what I'm doing now every time, then that's what you do. It just takes a little bit of time and you need space. X minus 3, x plus 1. So that you can believe me when I say what's left. Because timing with this LCD means that both of these denominator factors fall away. So I don't have another fraction anymore. It's only 5x plus 9 that's left. Actually, it's in a bracket and timed with 1, but you couldn't do it without the bracket then. For this one, the cancelling out would be the x minus 3's, but what's left is plus 2x times with
1.
x plus 1. This one, the x plus 1's cancel out. What's left, and it's after the equal sign, it's x times with x minus 3. So in this case now, I have to time all of that out again, and this is the sums that you've been doing forever now. The fraction sums you did in grade 10, but not as elaborate, as large, as many factorizations maybe, and things that you have to go and switch around. Something is added, but I'll add it at the end. So we've got 5x plus 9 plus 2x squared, because now we're doing distributive law. 2x squared plus 2x, and this is equal to x squared minus 3x. What type of an equation is this?
Quadratic.
The moment that you have an equation to go solve, you've got 3 choices. Linear, quadratic,
And
exponential. This is definitely quadratic.
Quadratic.
So what do we do?
Make it equal to 0.
Equal 1 side to 0. So we've got 2x squared minus 1x squared is going to give me positive x squared on the left. So I'll keep mine to the left. You're just as welcome to take it to the right and change the signs later. We've got 7x plus 3x giving me 10x. Then we've got plus 9 is the only thing that's left there. And this factorizes where that other one wouldn't have been able to. Now, if I go on with this sum, say for instance you did make a mistake. Somewhere you timed, I don't know how you did it, but this was maybe plus 11 or plus 14. There's no factors. Then what?
Formula.
The formula. Can it happen in such a sum? It
Yes.
feels too much. That you've got factorizing, that you've got LCDs, that you've got fractions, all this stuff happening here. It feels too much. But in essence, if you made one mistake somewhere with writing, maybe you wrote 19 here, which doesn't want to factorize now, and you carry on, you'll get it mark deducted for the mistake. But the rest of it you do correctly. I've got to give you all the marks. So if you had the wrong value here, but you did go for the formula and correctly got the answers in decimals, and got the answers back into the original, that's not simultaneous equations now. It's fine. One mistake, one mark. It does change the nature of the sum a little bit because now it doesn't have factors, but you're actually making it worse. But if you change it so that this becomes linear, that's such an easy sum then I'm not going to give you the full marks for the rest of the sum because it's now an easier level. So now we've got to factorize. We've got x plus 1 and x plus 9. Which you've got to go with your factorization technique, and your answers would be
X
is negative 1.
Or x is negative 1.
Okay, now we lost one mark for this sum, and I want to show you where. What are the red lights in maths?
The denominator can be 0.
The denominator can't be 0.
Can't be a negative.
So, when will this denominator be 0? Now I can't see. I can see it here. When will this denominator be 0? If x is 3, and look what happened. So that's where you're going to lose a mark here for not saying this can't be. That's why in these sums I want to teach you, together with the LCD, always write your exclusions. The moment that you've got fractions, but not just fractions, fractions with variables in the denominator, the possibility is there of having a 0 at the denominator at the bottom. When will this be 0? If x is 3 or x is negative 1. So 3 it can't be, and negative 1 it can't be. 3 it can't be, negative 1 it can't be. It's only those two. Then you go on with your merry sum, and at the end when you finish, you must know, no, that's not applicable because that will make the sum undefined. Why did it happen? Same basic reason as with the root sums when you square both sides. Why do you have to test at the end? Because you threw away the restriction of a root. The moment that you squared it and the root is gone, there's no more restriction. You've got to enforce it. Same thing here. You're throwing away the fractions. And the restriction then is gone out the window. You've got to enforce it at the end. So the moment you have fractions with variables in the denominator, you've got to tell me what are the exclusions and make sure that the answer is not there. Will it always be one of them that's not working? No. Lots of them do work. But in the case that it doesn't work, you've got to exclude it, otherwise you're going to lose one mark. So to get yourself in the habit is, when there's fractions LCD, the moment that you write your LCD, you should be thinking LCD, denominators can't be 0, so neither one of how many ever there might be can be equal to 0, because then the sum is undefined. Right, so what's my question? Solve for x. What do you see? Fractions. It's not exponential. It's not one with roots. It's not the stuff that you should be seeing here, exponential, etc. It's definitely just an equation, but I'm seeing the fractions. So the moment that there's fractions in an equation, only in an equation, you can get rid of the denominator by doing LCD. Can you see the LCD yet?
Yes.
No?
No.
You first have to factorize.
Factorize.
So your first step would be, and I'm just going to be lazy and say x minus 2, x plus 2 here. So your first mark would be for factorizing the difference of squares. Then my LCD is, please sit still, x plus 2,
X
x minus 2. And now I want you to remember it this way. That the moment that I do LCD, there's an exclusion. When will this be a problem? If x is
equals to 0.
2 or negative 2. If the factor is 0. So the factor will be 0 if x is 2. The factor will be 0 if x is negative 2. Will this be worth a mark here?
No.
No, just at the end. So if one of the answers isn't 2 or minus 2, then no problem. Then if you forgot to check the exclusion, you're lucky. Okay, not a mark there. But what do I then do with those LCD?
You have to like
You've got to go and time it out. I'm looking for my red, but I'm not finding it. There it is. So I'm timing here with x minus 2, x plus 2 over 1, which makes them fall away. Mission accomplished. What's the mission? I don't want
fraction.
fraction, so it's only x plus 6 left. Do it over here. You're timing with x minus 2, x plus 2. Doesn't matter whether I put it in the front or at the back. But every term, twice on the left and once on the right. No, that's not right. The whole side is timed. That means every single term is timed. And that side just has one. But it's still mathematically correct. Because you're timing the whole left side and you're timing the whole right side. With the LCD. Making fall away factors so that there's no more fractions. So what's left here?
Negative 2.
Negative 2 bracket x plus 2. Then is equal. Then it's negative 1 times with.
X minus 2.
And if you still got a floating denominator here, you missed the point.
Yes.
Then your LCD wasn't right. So now, normal sum further. We've got x plus 6 minus 2x minus 4 minus x plus 2. And let's add them together. What's going to happen here? X minus 2x plus x
Oh, x minus 2
is 0. Oh my goodness. First, before we go to the answer, is this linear or quadratic or exponential? Linear, so we're taking all the x to one side,
and
all the numbers to the other side. But what happened to x?
It
Minus
followed
2x plus x.
0.
Where's my x? Oh
Oh,
no.
it disappeared. Oh my
And on
god.
the other side, we've got plus 2 minus 2 is 0. Oh no. I'm trying to solve for x and my x is missing in action. We've heard about this before.
Yes.
What happens in a sum like this? Oh, fantastic. X is an element of the real numbers. Why? Because what's standing there is true. Always. Always. If it was 0 equal to 3, you'd say never. No solution. But I'm going to lose a mark because it can be anything, but not 2 and minus. So every number except for 2 and minus 2, and then you would have lost another mark again. Are you with me? Just do number I for homework then.